Hi, I'm Tom, coming to you from Cleveland, Ohio. Thank you for selecting my video. In today's video, we will be assessing the impact of bulk fermentation on the open crumb of a sourdough loaf. This is the third in a series of experimental videos I've been doing, which I call In Search of the Open Crumb. Now, how did we get here to this point? I started these videos about a month ago when, after participating in various social media groups and getting feedback on some of my videos, I was trying to improve the open crumb of my sourdough loaves, and many people were commenting that I needed to work on my shaping. So I started with an experimental video, which turned out to be the first in this series, which was called The Impact of Final Shaping on the Open Crumb of a Sourdough Loaf. In that video, I baked up 4 loaves of bread where I followed the exact same process up through pre-shaping, and then I only varied the final shaping of the loaves, and I did a combination of no final shaping up through very tight final shaping to assess the impact on the open crumb. What I found in that first video was very surprising, and that was, even though I did extreme differences in final shaping, the impact of final shaping on the open crumb was actually fairly minimal. It was much less than I expected. So then I created the second video in this series, which was the impact of pre-shaping on open crumb. In that video, I bulk fermented dough exactly the same way for 4 loaves up through bulk fermentation, and then I did 4 types of pre-shaping, starting with essentially no pre-shaping, where I took a slab of dough right from bulk fermentation and baked it, and then went through very loose or light pre-shaping up through very tight or aggressive pre-shaping and assessed the impact on the 4 loaves. Those results were surprising as well. What I found in that second video is that the open crumb was essentially set up coming out of bulk fermentation, and that the handling that I was doing in pre-shaping, for the most part, actually deteriorated the open crumb compared to what I had in bulk fermentation. So that was really a fascinating result. That does not mean to say that you should skip pre-shaping and that pre-shaping doesn't serve a purpose. What I learned in that video is that pre-shaping, in the absence of final shaping, because I didn't do any final shaping on any of those loaves, only gets you part way to your final crumb. So there's this transition from the setup of the crumb in bulk fermentation through the next 2 steps in the process, pre-shaping and final shaping, that are important. But the real revelation in that video was how good the crumb looked strictly coming out of bulk fermentation with absolutely no handling in pre-shaping and no final shaping. So that brings us to today's video, where we will look at the impact of bulk fermentation on the open crumb of a sourdough loaf. So in today's experiment, there are a lot of variables that we could change in bulk fermentation. So let me describe how I set up this experiment. When we look at bulk fermentation, we could change the duration of bulk fermentation. We can change the temperature that we're bulk fermenting at. And then there are all types of ways to handle the dough during bulk fermentation. What we are going to focus on today is strictly the handling aspect in bulk fermentation. So I'm going to make 5 loaves, and we're going to bulk ferment the dough exactly the same way in terms of the time and temperature. So we're not varying that aspect of bulk fermentation. And we will focus on 5 different ways of handling the dough. If you're interested in the impact of changing time and temperature on bulk fermentation, I have another video on that topic called Overproofed or Underproofed, A Tale of 4 Loaves. That video goes through 4 examples with varying times of bulk fermentation, and it's a great experiment if you're interested in seeing the subtle differences in longer or shorter bulk fermentation times. But in today's video, we will focus on the handling of the dough in bulk fermentation. What do I mean by the handling? By the handling of the dough, we have a lot of different techniques that are used in bulk fermentation for handling the dough. There are no-knead recipes where you essentially pre-mix all the ingredients and you let it sit and you don't do any handling. That'll be our first loaf that we will start with, is essentially no handling. And then there are other extreme levels of handling where people do a combination of lamination coil folds, stretch and folds. So what we will do is basically a continuum across the 5 loaves, looking at no handling to very extreme versions of handling, and then we will assess the difference in the dough at the end of bulk fermentation. The way that we will do that is we're going to bake up the dough coming out of bulk fermentation with no pre-shaping and no final shaping. So we're essentially cutting off the process at the end of bulk fermentation, throwing 5 slabs of dough into a shaping basket. We're going to shape these up overnight in the refrigerator for a cold-proof, cold retard. And then in the morning, we're just going to slash this dough and bake it with no pre-shaping and no final shaping. So the purpose of this experiment is really to isolate that impact of the different types of handling in bulk fermentation and how the handling impacts the open crumb. So in this video, we're going to do no knead, we're going to do stretch and folds, we're going to do coil folds, we're going to do lamination, we're going to do it all. It doesn't get much more exciting than this in bulk fermentation. So before we jump into the experiment, let's recap what actually happens in bulk fermentation. So I have another video on this topic called The Mystery of Bulk Fermentation, where I go through this in great detail. I'll give the very short version of it here. In bulk fermentation, there are essentially 3 members of the team that are building the dough. Number 1, you as the baker. Number 2, the yeast. And number 3, the lactic acid bacteria. You as the baker are essentially building the gluten structure or helping the yeast build the gluten structure. The yeast also assists with the development of the gluten structure, but the primary job of the yeast is to fill the gluten matrix with carbon dioxide. And the lactic acid bacteria is largely along for the ride, building flavor in the dough, but we're not going to focus very much on the impact of lactic acid bacteria. It's really about what you and the yeast are doing in bulk fermentation. When you ask people what happens in bulk fermentation, most people will say 2 things. Number 1, you're building the gluten structure. And number 2, the yeast is filling the gluten structure with carbon dioxide. In my other video, I used this cooling rack to demonstrate that, where essentially the first step in bulk fermentation is building the gluten matrix, which looks like this grid. And then the yeast, working at the proper temperature, fills the cells in the grid with carbon dioxide. That's what builds the structure of your loaf or your dough. But when you think about building the structure, how do you build the gluten matrix? There are actually a few things going on in that process. The gluten matrix is built by you, the baker, by essentially mixing flour and water. Immediately starts to build the gluten through a chemical reaction. The second thing that happens is the yeast actually builds the gluten structure by starting to give off carbon dioxide. It's doing what's called micro kneading of the dough. This is how you get a loaf to work when you do a no knead recipe. Without you handling the dough in any way, a no knead loaf actually works even though you didn't touch it, because the yeast is actually doing something to build the gluten structure. Now, to illustrate that, when we build the gluten structure, the baker, by reaching in and doing the stretch and folds and stretching and coil folding and laminating, and some people will knead the dough, we're doing, the big bungee stretches of the dough, really grabbing big chunks of it and stretching it to build elasticity. What the yeast is doing right from the start, from the point the yeast hits the water and flour in the premix, and the yeast starts giving off carbon dioxide, the yeast is doing what's called micro kneading, like this little rubber band. Every time the yeast gives off carbon dioxide, it's doing millions of tiny stretches of the dough. That's called micro kneading. So the yeast is also building the gluten matrix. And this will be important to understand as we go through the experiment, that building the gluten matrix is a combination of what you are doing and what the yeast is doing. Once the gluten matrix is created, then the yeast goes along its way and fills up these little balloons, these cells within the gluten matrix, to rise the dough or build the height of the dough. That's the basics of what happens in bulk fermentation. But what's missing from that is that when I describe the gluten matrix, and I'm showing it here as this 2-dimensional grid, what happens in bulk fermentation is that as the baker, when we are building the structure of the gluten, we are also building height in the dough. And this is the purpose of the folds. When we start to fold the dough, we have one layer of gluten, we stretch it, we build another layer of gluten. We stretch that, we build another layer of gluten. We stretch that, we build another layer. So through the bulk fermentation process, we're building 1, 2, 3, 4, 5, 6, keep counting. Every time you touch the dough, you're building layers of the gluten matrix. This is incredibly important to understand because this is the point of today's experiment. All of the handling that we do in bulk fermentation isn't just about building the grid, it's about building the layers in the grid. So as we go through the experiment, keep that in mind because the number of layers that we build in each one of the 5 loaves will be an important variable to understand. So now let's talk about the methods of dough handling in bulk fermentation. These are the methods that build the height of the dough. There are essentially 4 methods that we'll talk about today. These are the 4 most common methods that you'll see across the vast majority of sourdough recipes. The first method of dough handling in bulk fermentation is no handling, and that is the no knead method. So what happens here, you mix up the dough, you add starter water and flour, you do a shaggy ball of a mix, you let that sit, and you don't touch it. You don't do any handling. So in that case, as I mentioned in the prior section, the yeast is doing 100% of the work of building the structure of the dough and building the height of the dough. So no knead will be the first method that we will look at in the experiment. The second method is a method popularized by Chad Robertson in the Tartine Bread book, and that's the general recipe that we'll be following here. And the stretch and fold method is a technique used specifically in sourdough baking because of the wetness of high hydration dough and the stickiness of the high hydration recipes. It's very difficult, or not, if not impossible, to knead the dough using kind of the classic kneading techniques. So all of these techniques are basically ways to build structure and build height without kneading the dough. Stretch and fold is one of the most common methods. In the stretch and fold method, which is shown here, you essentially have your pre-mixed dough ready for bulk fermentation. You grab one side of the dough, you pull it up out of the bowl, you fold it over, you turn the bowl 90 degrees, you go around and repeat that 4 times around the perimeter of the bowl, essentially doing 4 folds over the top of the dough. So you're essentially building 4 layers here. And as I mentioned, understanding the number of layers is incredibly important. So let's show an example of how to understand how many layers are created in stretch and fold. And I'll use this piece of paper. In stretch and fold, you have your ball of dough, you pull one side of it, you fold it over, you turn it 90 degrees, you grab the second side, stretch it out, fold that over, turn it 90 degrees, stretch the third side, fold it over, turn it 90 degrees, stretch the fourth side, fold it over, and you're done. So that's considered one rotation or one set of stretch and folds. So what did we actually do here, and why did I use this paper to do this little origami? I'm going to cut the corners off of this and show you what happened here, and we'll do this for the other methods as well. So in stretch and fold, I took my dough and I folded it over 4 times. So I had my original layer of dough, and then I folded 1, 2, 3, 4 times. So I added 4 layers to the gluten structure by doing that one rotation of stretch and fold. So keep that number in mind. The next method of handling is called coil folding. Let me show you an example of how coil folding works. I lift the front, leave the back attached, fold it under, lift, and fold. That's a good coil fold. Turn it 90 degrees, do the same thing again from the other angle. Lift the front, fold it under, So coil folding is a little tricky until you've done it. I've only done it once before, so I'm going to be learning on the fly today. So let me just demonstrate it a little bit differently using this kitchen towel so you can see it again. So if you imagine your dough sitting in your casserole dish, the way that I think of the coil fold is I grab the front 1/3 of it right here. I'm not really grabbing it in the middle, I'm grabbing it towards the front. I lift it and I fold the front under. Then I turn the dish 180 degrees, so I'm turning it all the way around. And then I lift the front again, this used to be the back. I lift it again and I fold it under. So what I've just done is I've created 2 layers, and the coil is, when you look at it this way, if this were round, this looks like what reminds me of one of my favorite foods as a child was the Little Debbie Swiss rolls. Here's a picture of one. That's the coil fold. It's essentially making a Little Debbie Swiss roll. But I'm only halfway through this, so that's the first part of the coil fold. Then you turn it and you do the same thing again. Now I've already got 2 layers underneath my original layer. So now I lift the front third, I fold it under again. I turn my dish 180 degrees, I lift it and fold it under again. So that's the essence of the coil fold. It really, to be more technically correct, should be called a double coil fold because I'm really doing it 2 times. Even though I'm doing 4 folds, I do the front half and the back half. I get 1 coil, then I turn it 90 degrees, I do the front half and the back half and get my second coil. So that's the double coil fold, commonly known as coil fold. It's a little confusing though when you look at this. I can't really tell how many layers I created, so let's do the paper trick. I have my dough sitting in the pan, I lift it up, I fold the front third underneath, I turn it 180 degrees, I lift it and I fold the former back third, which is now the front, underneath. So I've done 2 folds so far. Then I turn it 90 degrees, I lift it, I fold the front third under, I turn it 180 degrees, I lift it and I fold that former back third under. So this is what you get when you do a coil fold. How many layers did we create here? Let's take a look. So how many layers do we end up with in a coil fold? 1, 2, 3, 4, 5, 6, 7, 8, 9 layers. So I had my original layer that I started with. I ended up with 9, so I've added 8 layers by doing a coil fold. So compare this with what we found in stretch and fold. I had my original layer, 1, 2, 3, 4 new layers. So this is fascinating. In a coil fold, I'm essentially creating twice as many layers of dough as I am in stretch and fold. So this raises all kinds of interesting questions. If I just did 2 times as many stretch and folds, do I get the exact same result as doing a coil fold? We'll find out, because that's part of how we'll do the experiment. So very important to understand how many layers you're creating in these methods. And then the last method that we'll look at in today's experiment is something called lamination. Here's a video of how lamination works. Now with lamination, basically what I want to do is stretch this out as thinly as possible, as if I were going to make a giant pizza dough out of this. So the first thing I do is pull it to this side. Next, pull to this side. And then I pull from this side down here. I'm really getting a good stretch here. You can see that the gluten is developing nicely. It's almost like I'm doing a giant window pane pull here. So I stretched this out roughly into a giant square that looks like if I were going to make a giant square pizza, which is incredibly tempting right now. But I'm not going to do that. In the interest of science, we need to keep moving along. So now the lamination is basically I do 3 tri-folds. I grab the top, fold it 1/3 of the way over. I grab the bottom, fold this over. I grab this side, fold to the center, and I grab this side, fold to the center, and there I have my nice, neat, laminated package. So how many layers do we get here in lamination? We do the origami paper trick. I fold one side over, I fold the second side over, I fold my top down, I fold my bottom up, so how many layers do we end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9 layers. Same as coil fold, original fold plus 8. Here was my coil fold. 1, 2, 3, 4, 5, 6, 7, 8, 9, original plus 8. Stretch and fold, original, 1, 2, 3, 4. So stretch and fold, I add 4 layers. Coil fold, I add 8 layers. Lamination, I add 8 layers. Very important to understand this because this is the basis of the experiment. It's not so much about the technique, it's really about the number of layers that we create. But then you have to ask the question, if I get the same number of layers through coil folding and lamination, why am I doing both of those? What's the difference between those two things? And this brings us to the last point of the handling techniques in bulk fermentation, and that is the stretching aspect. So we're not just folding layers. In each one of these techniques, we're also doing stretching. So now let's think about in the stretch and fold method, I'm doing a lot of stretching where you could see in that video, I pulled that dough way up out of the pan. So stretch and fold method is a little bit more about stretching and a little bit less about creating layers. You're getting 4 layers out of each stretch and fold, but you're really stretching the dough and you're building the elasticity of the gluten. The coil fold is an incredibly kind of gentle way to stretch the dough. So coil folding is more about the layers. You're trying to build the layers, but when you see people do coil folding, they handle that dough incredibly gently and gingerly because you're trying to not handle the dough too much. So it's a very gentle mechanism or technique for building a lot of layers in the dough. That's coil folding. And then lamination, the third method, is a little bit of a combination of both, where we actually did a big stretch on lamination. You could see when I was stretching that dough out into the big square, I was really stretching that to the point where it was almost ripping. So lamination is doing both things. It's stretching the dough more than in coil folding, and you're building those 8 incremental layers through lamination. So as we think about these 3, keep those aspects of each technique in mind. So this is the point in the video where you're probably asking, when is this guy actually gonna make the bread? We're getting there. Okay, let's talk about the 5 loaves. So for today's experiment, we are going to be doing 5 loaves of bread. I'm following the basic recipe of the Tartine Basic Country Loaf. So what we will do in that recipe, it starts with a fermentalise where you add starter, water, and flour. Let that sit for about 40 minutes. Then we will add salt, let that sit for 20 minutes. That basically gives us our first hour of pre-mixing. That'll be the same for all 5 of these loaves. Then when we start the handling portion of bulk fermentation, that's where all 5 of the loaves will be different. So the 5 loaves are, number 1 is the no knead loaf. This is where we're basically going to do that pre-mix. We're going to carve off 1/5 of the dough. We're going to put that into a vessel, let that bulk ferment. We're not going to touch that. That's the no knead loaf. We're going to bake it up later without any handling at all. No stretch and folds, no coil folds, no lamination, no nothing. The second loaf will follow the tartine bread recipe and process very closely. And tartine is a relatively light handling recipe. So I'm going to call this number 2 loaf tartine light. We're going to follow it by the book. We're going to do 4 stretch and folds, and then we will basically not touch the dough. After that, we'll let it continue to bulk rise. We'll bake up that loaf after 4 stretch and folds. Importantly, as we go through each one of these, think about how many layers we're creating through our handling. In loaf number 1, the no knead loaf, we're not creating any layers. We're letting the yeast do all the work. We're going to see what the yeast can do. Loaf number 2, we're doing 4 stretch and folds. Each stretch and fold creates 4 layers. So we're adding 16 layers to the structure of the gluten in the tartine light example. The third loaf is what I call tartine heavy. And this is where some people use their own interpretation of the tartine recipe and they continue stretch and folds through bulk fermentation. So in this example, we're going to do 8 stretch and folds. This is 2 times the minimum recommended amount in the tartine book. It gives you the option to do more. Most people do 4. This is for people who can't keep their hands off the dough. They just keep touching it. We're going to see what 8 stretch and folds do to the tartine method. That's loaf number 3. 8 folds times 4 layers in each fold gives us 32 layers in the dough. So it's 2 times the number of layers that we created in the tartine light version. Then in the last 2 loaves, number 4 and number 5, we're going to do coil folding. So the loaf number 4, we will basically do 4 coil folds. So if you recall back to our experiment, every time we do a coil fold, we create 8 new layers in the dough. So this one will be 32 layers that we're creating by doing 4 coil folds. So that's the same number of layers as doing 8 stretch and folds in loaf number 3. So that'll be a great comparison between the two. 32 layers created through 8 stretch and folds, 32 layers created through 4 coil folds. Those loaves will be really interesting to compare. And then loaf number 5, this one is the full Monty. We give it everything. We're going to do 5 coil folds and lamination in loaf number 5. That's going to create 48 layers within the dough. So that'll really be our extreme handling loaf number 5 with 48 layers, and we'll compare that to all the others. Those are the 5 loaves. Now let's get down to baking some bread. In all of these experiments, I follow the same recipe for consistency. I use the tartine bread basic country loaf recipe. Let me just give you the quick rundown of what's in that recipe. The recipe typically calls for 1,000 grams of flour, which is a 90% mix of bread flour, 10% whole wheat flour. In this example, because I'm doing 5 loaves, I'm going to bump the whole recipe up by 25%. So my total flour weight will be 1,250 grams of flour using that 90-10 mix of bread flour and whole wheat flour. The hydration of this recipe calls for adding 75% water based on that flour weight, 20% starter. My starter is a 100% hydration starter. It's actually 11 that I made last night. And then we add 2% salt. So those are using the baker's percentages: 1,250 grams of flour, 75% water, 20% leaven, 2% salt. That's the basic recipe.